Good morning, everyone. Happy Friday. Thank you so much for being here. We had a really great response for this topic. I think it's one that a lot of people are interested in. This is the very first time we had to restrict in-room attendance because we have more people than we have capacity. So we have several people joining us online. There's still seats here available. So if any of you are sitting in your office, you want to come join us, I think we have a few seats here, unless you have someone that's constructing in. I'm Wayne Wright. I'm the Associate Dean for Research, Graduate Programs, and Faculty Development. And it's my sincere pleasure to start off our first Power Friday of the academic year. And I'm very pleased to have Dr. Kyungbin Kwon from Indiana University. I went to ARA, they had a session there about AI in education, and Dr. B and some of his colleagues were presenters. And I went up to them and said, hey, I need to have you come to IU. I had you come up to Purdue to share with you what you're doing. He was very gracious to come and spend some time with us. We also, of course, have our own expertise here in-house. And so we have some of our own faculty and graduate students be presenting as well on a panel afterwards. So I'll do a quick introduction for Dr. Kyungbin Kwon. And then after his talk, we'll transition, we'll set the panel, and then we'll do some introductions for our panel members as well. So a little bit about Dr. Kyungbin. That's not my paper. Did you see my introduction page? I'm going to remember everything I can then. Well, I think that might be it right there by flaw. Oh, yeah. All right. So Dr. Kyungbin Kwon is an associate professor of instructional systems and technology and the School of Education at Indiana University. Been there 9 years. Is that right?
Yes.
Graduate from BizU. In the learning technologies, info sciences and learning technologies from the University of Missouri. So his work focuses on facilitating positive interactions among students and context of computer-supported collaborative learning and designing effective instructions for computational thinking. His research accomplishments and interests emphasize innovative uses of instructional technologies to establish learning communities and enhance learning performances. Overall, his research impacts understanding learners' collaborative learning processes, designing effective learning environments, and fostering productive learning communities and enhancing problem-solving performances in various contexts. In other words, he uses technology to do some really cool stuff in classrooms with students. And so looking at some of the research projects he's involved in, he's the PI on a couple of NSF grants, including one called AI Goes Rule, Middle School Artificial Intelligence Inclusive Education, which I think he'll be talking about today. He's on another grant that deals with mixed reality for inclusive and embodied learning experiences for young children. And some other grants that he has includes things like computer science education, augmented reality, and many other things. So we're very excited to have you here. And with that, turn the time over to Dr. Kwon.
Thank you for the kind instruction. Actually, let me correct one thing. This project is supported by DoD standard NSF. So,
Defense.
yeah,
Okay, thank you.
yeah. Okay, thank you. Click this.
I can. Try now.
Yes. Okay, good.
Yes.
So I'm going to talk about why AI education now, right? Yeah. So it's not a kind of a new question for us. Now we talk about why we teach AI to the young kids even. And many scholars mentioned that only exposure to the AI education can shape their knowledge-based knowledge and even their attitude towards this subject, right? So it's not only for the AI, it's also applied to the STEM education and other education, right? So when we expose to a certain context or subject early enough, we shape our interest toward that and we build our competency early enough, right? And we can improve more, right? That's kind of general argument regarding the AI education. And we also want to build some competency for our society. That's why many countries pay more attention to the AI education. Yeah, China, Korea, Japan, and the European country, especially USA, we focus on AI education because it depends on this education system. Our future will change, right? That's why U.S. government pay more attention to AI education. And now AI education is not for specific people, it's general education. So we say digital literacy, right? So it is important to build that kind of competence for everyone. So I think why should we teach AI? It's not a new question, and I assume that many people agree with that. Even 2 years ago, when I have the faculty meeting with our colleagues, we talk about computational thinking education, and one of my colleagues asked me, "Why should we teach CT to the young kids? Even there are many other subjects that we need to teach, right?" And I explained something, but it was not persuasive to her, right? So there can be still some kind of argument about why should we teach AI? But I would like to change this question different way to how we can teach AI, or what should we consider when we approach this AI education like this. Equitable access. As you agree that AI education is very important for young kids, especially when we access this AI education, they have potential to build up their career and the potential to build up their other academic skills through this. So it's very beneficial. But the issue is this good thing is not accessible to everyone equally, right? Especially when we think about the girl and boys, they're different, right? Actually, recently I conducted a literature review about the gender difference in city education, and we found that in early stages, such as first grade and second grade and third grade, we do not find any gender difference significantly in the STEM education, even in the city education. But when they go to the middle school and go to the high school, this disparity increased. That's the issue, right? So in the early period, we need to handle this one. We want to tackle this one. And another issue is teacher training. In rural area, especially, not many teachers can teach AI education, even the computer science education. They need to learn and they need to get some kind of pedagogical strategy to teach new subject. So they need. And there are many concerns about using AI for their learning. As ethical issue and the responsibility issue, right? So as you know, New York district banned ChatGPT for processable reason. But recently, they changed their policy. They now allow ChatGPT for student because they knew that there's an ethical issue we need to consider. However, that's not a reason to ban advanced technology to our student. Yeah, that is an educational issue. So we need to solve that issue educational way, not the technical way, right? So detecting the using the generative AI, that's another technical issue. But we can solve this ethical issue in educational approach. So there are many other things we need to consider, but this is not a reason we can ban the advanced technology to our students. And curriculum development is a very demanding need. Even a teacher want to integrate the AI curriculum into their subject, they need some curriculum. They need help. It's many good initiative open their curriculum to the public so we can use it, and that's very encouraging. However, still, if I am a math teacher, I need some kind of a curriculum tailored to my subject. So in that case, we need a curriculum development, and we need to let teachers get used to the AI learning tools. And it is almost impossible practically to set up AI curriculum as a one subject in the high school, even the high school. And when we consider the elementary school, it is impossible. And I don't think it's a good approach towards the AI education. AI education should be integrated in other subjects. So students understand the AI concept while they learning math, or even English, and even social study. They learned how AI works and how they use AI for their study. So I emphasize that AI education cannot be a standalone subject. It should be integrated into other subjects, especially in the K-12 context. So keeping this issue in mind, I look up the Indiana public education status. When I heard about the ratio to enter the college after they graduate high school, now I think it's less than 50. You see this one, this is 2020, and only 53% of high school senior enrolled in college. I was shocked when colleague mentioned about the listen to data. I couldn't believe it. Wow, less than half. And when this happens, the underserved population affected this kind of fact more seriously, right? So here, low-income students, only 30% of students from the low-income students enrolled in the college compared to the high-income students, 60%. Big difference. And 40% of rural high school graduates are from the low-income family. So it can be very serious. And compared to the rural and non-rural schools, the rural school students are less likely to get into the college. We do not consider the level of college such as a community college or like Purdue, right? Yeah. And when we consider AP classes offered in the high school, the disparity will be more serious. And when we think about after-school activities, the rural students do not have that kind of accessibility. So keeping that in mind, we go to the.
Sorry,
Yeah.
pardon me for 1 second. I'm sorry. It dropped you, it dropped us out of the meeting and I
All right,
want to get
yeah.
it back in for everybody else.
Please take your time. Yes. Actually, through this project, we luckily got this fund from the DoD, and Michael, would you? Okay, let me.
Yes, you go right ahead.
I wanna show my colleagues
Ah.
who work with me. So this is our website, AI Goes Rural, and there is a team, and Tina is the Crane K-12 STEM coordinator. We could submit our proposal through her to the DoD, and because DoD has some kind of specific limitation, so I cannot directly submit. And we have some wonderful colleagues. Like you may know Anne Leftovich, right? Yeah, she's a graduate from here in Purdue, and Krista Glazowski, she was a department chair, but now she is in NC State. Yeah, and we have two computer science professors, Memo and Raji, and we have a wonderful graduate students who work with this project together. Last but not least, even more important, we have these participating teachers who actively engage in this project, and we have these teachers from all around Indiana, especially near to Bloomington. Yeah.
I can start back for you.
Oh, thank you.
Welcome.
So the goal of this project is to build teacher competency to teach AI computer. many of the participating teachers has experience in teaching computer science. They knew Scratch very well, and they knew how to teach CT concept to the student, but they never think about AI in their curriculum. So it's their first time to introduce the AI curriculum. And through this project, we want to build a curriculum that can be integrated into participating teachers' class and even expand the scope to more teachers. And the curriculum emphasize the practical use and the moral consideration of AI. That's the kind of big goal of this project. Would you please click this one? Thank you.
Oh, we're doing that again. Yeah.
Yes.
Sure.
Okay.
Oh. Did I go too far?
Yeah, I think it's all.
Okay.
Thank you. So this is a 3 years project, very short period. We are in the 3rd year now, and as you can see, this project we provide PD and co-design session for the 1st year, and this teacher continue and they developed a curriculum with us. So 1st year's main goal was develop AI summer camp curriculum, and we worked with the teacher as a co-design process, and we designed the AI curriculum, and we successfully offered the summer camp. And the next year we expand the participating teachers and continue and especially implement the AI curriculum into the participating teachers' classroom. That was a huge success in this project. And a few months ago, we offered the summer camp, and we revised the summer camp based on the experience, and it was successful. And this year, we want to build teacher community. So here, the participating teacher, they were wonderful, and they learned a lot in short time period, and they boost up their self-efficacy towards the teaching AI curriculum. They think they are master, yeah, and I think they are master in that area, and they can be a mentor to their neighbor teachers. So we are thinking about that one. So through the teachers' resource, we can build up the teacher community in our rural area. And we want to continue implementing the AI curriculum in their classroom. And this is the area we have the teachers. So as you can see, we developed the AI curriculum with the teacher through the co-design process. Even we provide the PD. And the curriculum is implemented in the project leads the way in the curriculum and the computer science course and digital citizenship course. So it was integrated into that school curriculum. In terms of the period, mostly teachers integrate 2 weeks activities. So student has 5 days through the 8 days activity. So compared to the summer camp curriculum, it's very short. Yeah, summer camp is 5 days from 9 to 2 or 3. So it's very intensive course. But we cannot do it in the school context. So we reduce the curriculum and expand it to the 2 weeks or 1.5 weeks, like that. And we serve the rural and the underserved areas like this. So as a progress, we provide the PD and co-design session with teachers. And before we have the summer camp, we have on-site teacher workshop day. So teachers get through the summer curriculum in 1 day as a student, and they practice it. And after that, they have a chance to lead one of the summer camp session by themselves. So it was a kind of a strategic approach that build the teachers' knowledge and skill and gave them some kind of opportunity to practice, and that build up their self-efficacy towards this area. So eventually, last academic year, we solved around 400 students with this curriculum, and I think this was a very impressive number. So let's talk about how we can empower our teachers. They need help. They need support. Actually, I was surprised that our teacher was so wonderful. They want to do something, but they need something to do that, right? Yeah. So we really considered how we can empower teachers. So the first approach is professional development. We can provide professional development. And this is, I think, the most common approach toward the teacher education, providing PD. They need it. And especially in the, I think Korea and China has a similar situation. When government think we need to teach AI, and then, okay, good, this is made in January. And in the summer, when the teacher has a summer break, okay, let them go get together and provide the PD. And in the fall semester, let's do it like that, right? So it can be done in country like Korea. The government can control most of the things. But I learned that in America, even Barack Obama emphasized we need to teach CT. But yeah, doesn't change it dramatically because the state has a kind of right to control the state's education system. And also teacher has their own authority to select the curriculum like that. So you should change from the root. Yeah. So professional development is very effective method to build up some kind of competency for the teachers. However, there's some limitation. As we know, that if the PD should be effective, it should be tailored toward the teacher's need, teacher's context. If not, it's just overall overview, and the teacher should do by themselves to make it effective in their classroom. And usually PD is a 1 week or even 1 day workshop, just an event-based one. And after that, teachers are alone in their classroom. Right? Yeah. So that's why there is some issue. And about the teacher self-efficacy, I'm not sure how PD boost up teacher self-efficacy. So we empathize, even we provide PD to our teachers, we also think about participatory co-design. And through this one, we want to respect the teachers' pedagogical knowledge. And even we respect their willingness to take a risk, to take one more step towards the student. So through the PD participatory co-design, we want to build competency for our teachers. However, there's some issue we need to consider. Actually, we respect diverse expertise. The researchers have their own strengths, but they have their own weakness too. Teachers, practitioners also has their own strengths and even weakness. So we should respect the diverse expertise in this process, but researcher may focus on the lack of content knowledge because we are introducing new content, new concept. Maybe teachers themselves may focus on their lack of content knowledge. This make this co-design process very difficult. At the beginning, I show you some picture in the initial meeting with the teacher. One teacher was very reluctant to engage in discussion and very dispensive when we ask some kind of a suggestion. I think when teachers position themselves as a less knowledgeable person, it happens. So we keep encouraging them. We are not expect knowledge from you regarding this the content, you definitely will catch up this one quickly. But we want to have your expertise in your pedagogical experience. I think that's the key point in the co-design. And the sharing authority is also important. We try hard to share the authority, but sometimes I observe that teachers perceive that the professors, yeah, something like that. Even we didn't intended, it may happen. So we need to be intentionally careful about that and make a more, how to say, not a democratic environment. Yeah, even, yeah. So we need to try hard to make that kind of environment that teachers feel comfortable and feel safe to open their mind. So throughout that sharing common goal and expectation and specify the roles, we try to make that kind of environment. And this is the most difficult things, patience to the uncertainty. I'm kind of a person that plan everything in advance. When I go to conference, I plan everything. And my wife is opposite. Yeah. So last summer I went to Austria, Vienna. I plan everything by time every day. So enduring the uncertainty is very difficult for me. But when I lead some session with my teachers, I should bear the uncertainty because I should be flexible toward my teacher's suggestion. And even at the beginning, we do not have a clear goal about how our AI curriculum will look like, right? I didn't set the kind of a goal in front of my teachers. I would like to, based on my personality, but I didn't do that. Yeah. So I enjoyed the uncertainty, but sometimes it's difficult. Yeah, even teachers is difficult. Teachers sometimes looks puzzled. What should I do in this situation? Something like that. Yeah, right. So the lesson I learned through this co-design session is build the rapport is very important. The lady looks even sad and defensive at the meeting. I surprised when I meet her in person. She's so sweet and she's so acceptable, and she even opened her class with me because her student was not kind. I was shocked when I saw the mean student to the teacher. Sometimes the students were really mean to the teacher. Wow.
Middle school, right?
Yes, middle school. And the teacher actually served as a company as a software engineer for a long time, and she changed her career to the school teacher. So she lack of teaching skills. She struggled. So I think that's why at the initial meeting or early meeting, she was passive. But when we build a rapport, she opened her class. So we went there and support her. Even we support each other and blame other kids behind. With her self-reflection, yeah. Put the bandage on her mind. And commitment. Yeah. As you can see in the Google map, this is the one school in the Lugari community. It takes a 1 hour drive. And as you can see, the middle school classroom is only 40 minutes or 45 minutes in one session, right? To support our teacher, we drove there and observed there around less than 1 hour and drove back. It is not easy. It's not easy for me And it's not easy for my students too, right? Graduate student. Time is very precious, right? Most precious one for my graduate student. Yeah. They spend day to support our teacher. And the teacher respects this commitment. And eventually the teacher is over here. She came to our summer camp, 1 hour drive to the IU for 5 days, full day, no excuse, no absence. So each other, we come to each other. And we gave teachers opportunity to shine. As I mentioned, teacher lead the session in the summer camp. And they lead the classroom activity. Sometimes what I shared previously, the lady, she has a teaching skill. She felt she doesn't have a teaching skill in this context. So at the time, for the first week of the session, we went there and lead the session for her class. And after this session, the next cycle, she said, now let me teach in my class. And I think it pushed up her. And this is a public news, and our teacher show up in the front page like that. So I think this is let them feel shine in that sense. And we empathize that even though we build this relationship based on this project, we want to keep this relationship. And I want to keep this relationship with our teachers, and they knew that. And when I apply a new grant, I will get the collaboration letter from them. So it's kind of a win-win, right? Yeah. And I found that in-person meeting is very important because our teachers are all separated. So it is very difficult to get them together and have an in-person meeting for every meeting. But we need at least a one-time person communication. Through the online, we can share information, but there's a limitation to share some feeling of community, feeling of belonging. When we get together in like this and practice the AI learning tools together, we even share some feeling of belonging together. So that's why I think in-person meeting is important. That's what we learned through the co-design session. And now let's talk about the enriching the student learning. Yeah, I think I need to hurry. So AI concepts is very abstract, right? So it's very difficult to teach even the middle school student, even the elementary school student, it will be very difficult. So we need to consider that AI concept is very abstract. And it is not stable concept. It changes a lot, right? The AI concept 10 years before is totally different from the concept now, right? Even the concept is evolving every day, right? So it's difficult. And many pedagogical approach toward the AI education is a black box approach. Here's the input, and here's the outcome of the AI model. Now we use this AI model for this. We make this one as black box, right? So for this, many scholars trying to make this one as white box. So let students understand what's going on here, how the data quality affect this model, how the quantity of data affect this model. Is there any kind of bias involved in this process? Like that. That should be explained. So to do this, we want to survey students' live perception about AI. We want to see what perception they have at the beginning. So we use the AI or not AI practice, and we want to analyze their presentation. We want to see their learning activities, and we catch up their conceptual understanding of AI. And this one came from the first summer camp. We had 14 students, and we used the inductive semantic analysis. And we found that student has a very naive conception about AI. First of all, students do not tell the difference between automation and AI. They think automation is AI, such as when I go to the highway, we collect the toll automatically. I think that can include AI, but basically that is automation. In the car company, each robot do their own task based on the module. It's an automation. It can include the AI component over there, but basically it's automation. So we want to let students to tell the difference between automation and AI, and rule-based or data-based. Right? And students think about AI can do everything. That kind of concept we need to change it, and AI born as a smart. Actually, it's a big misconception because we human train AI, right? Yeah, based on our own data. That's why we need to think about ethical consideration. And this is a very important finding that we from the students, that students think AI doesn't have emotion. Do you think AI has emotion? No, many people know, right? Maybe yes later, but I'm not sure. I don't think AI has an emotion like a human being. So that's the why AI is impartial. That's why AI is biased. That's our students' rationale. In a certain point, it makes sense, right? Yeah, because they do not have emotion. He is my preferred friend, so I will give more something like that. Yeah, AI cannot do that. That makes sense, but actually AI has a bias and AI has some kind of a limitation. Depends on the training data and the algorithm, right? So we want to emphasize that. So when we design the curriculum, we heavily integrate the hands-on activity, and we want to provide the authentic learning context so students can understand the AI concept based on their daily life. And we want to let students develop their own project. Throughout that process, they think about what AI can do and what AI cannot do, and what should we consider to use AI more ethically. So we taught machine learning, computer vision, and the natural language processing. And we definitely invited experts in that area. And we also invited the engineer in crane area, the military engineers. We invited them as a judge when students presented their project. And they shared lots of good insight to the student. So that was good. And we want to let students reflect on their learning. And we would like to let students collaborate each other and discuss about their idea together. And definitely there was a lecture, but we minimized the lectures, considering the our students. So how many of you know about AI for ocean? Oh, not many? Okay, good, okay. Oh, so yeah, good to know that I can provide the new information. Yeah, so AI for ocean, you can just search Google and AI for ocean. This is very easy way to teach supervised machine learning. So students say that this is a fish, and there's some garbage, and this is not fish, something like that. So student can categorize the input data, and the system generate an AI model based on that teaching. Throughout that, students can build up their own AI model, and the AI model can tell this is a fishy and this is not fishy, like that. And sometimes this fish has a square, right? Other fish has a triangle. And if this is a new data, and AI detect this one is not fishy based on other training data. That kind of activity make the black box as a white box to the student. So students understand how AI generate the model. Okay, and after that, we ask some kind of reflection question like this activity. And this is some activity regarding the machine learning. So the first one is student can send a text message to their parents using AI. Second one is make a game. And third one is a squat. So AI can detect the pose and make it, you did this one time like that. So count it. So let me show you this one briefly. So text method, we provide the context and let them use the teachable machine. So teachable machine is also, let me show you the teachable machine. So here, the teachable machine also very easy learning tool, AI tool. So students can put the data here. This is the audio data. So teachable machine can have audio data, also image, also pose. So teachable machine can train the audio based on the student's input and train the model and make the AI model. So students use this one. So here first one is daddy call me. Or second one, mommy, I need your help, like that. So based on this input, AI developed a model, and this model can be uploaded to the cloud. So it may be sounds scary, but it's very easy. If you go follow this step, you can do it without any support. Yeah, and our website aigoesrural.iu.edu, you can find this material. Yeah, you can find it step by step. Anyway, students can develop their own AI model and upload it and use it for their own application. So we use this website and put the AI model here and let them make it dad or mom. And based on the categorization, the text will be sent to their parents. This activity we use and they had a discussion with the student. And this is what I mentioned about the teacher. They use a teachable machine and recognize the pose, and it said squat up, squat up, right there. Yeah. And here's another example: the garbage collector. Let me. Yes. I think this one. Yeah. This is my graduate student, wonderful guy, and he made this demonstration. So using the teachable machine, he trained the pose, and based on the pose, the AI model detect the sign of this and make this garbage collector move around to the garbage. And it's like a game, and it uses scratching. So it's not difficult. They use a teachable machine and build up the AI model and integrate that one to the scratching and make it doable. You go back to yeah. Thank you. Yes. And we want to make the project-based learning so students have a very structured guide towards their project, and they define the problem and generate concept and develop solution and draw the prototype. Actually, it is a kind of a prototype development, so they do not develop their own actual application. I will show you this prototype, and they present and revise it. All this one guided through the very specific scaffolding, and I do not have enough time, so let me skip. And this is the one example, the outcome of their prototype. And they made a smart home, and as you can see, the roof is changeable. And change is a kind of opacity and reflect the sunshine based on the weather, the temperature. I'm not sure it's really AI oriented, but when they explain they use the AI term and they have their own rationale regarding this. So that's a very kind of impressive moment, learning moment for us and even for the student. And they also have some kind of a water to chill down the home temperature, and it is generated by AI. And this is a kind of another game. So they want, I think it is a boy group. They developed the AI oriented game system, and here you can see, yeah, Xbox and. Anyway, they have their own idea about this, and here dishwashing and how do they save water and how do they control the temperature. So we recorded all their presentation, and now we are analyzing their presentation. Through that process, we can catch how students' naive conceptual understanding of AI changed, and what is still some area to improve. And regarding the learning outcomes, we found that significant increase. I think it's not surprising result, right? Yeah, for 5 days activity, there should be some kind of increase. So it's not surprising. Yeah, if we didn't have that result, we would be disappointed. But yeah. And regarding their belief and attitude, we also find some kind of increase. And more significantly, we didn't want to finish our activity in the summer camp. We want to let teachers integrate this summer camp curriculum to their classroom. And this wonderful teacher, Kevin, integrate this AI curriculum to his not computer science class. And the topic was healthcare. And what you see there is the cancer in brain cancer here and no brain cancer, and the two different images. And the teacher used these two different images to train AI model using the teachable machine. So put the two different images in the teachable machine, and the teachable machine generate AI model. And he used new images and let the AI can detect this cancer or not. And here, another teacher in the Luguri area, she implemented a smart home design project in her class, and even the student developed a smart farm. And what I remember is the cute guy make the project that there is a kind of, because they are rural area, there are many other wild animals. So the AI detect the shape of animals and open door, the cat door, open cat door for their own cat, not other wild animals. I think that's kind of a brilliant idea. That kind of a thing happens. And regarding the future direction, we want to build a teacher community, as I explained, so to expand this scope. And we want to analyze learning experience more, not just pre and post tests. We want to look into their learning experience and how they change and how they improve. And some longitudinal study is necessary, especially toward their career path or career selection or choose of subject in high school. And another very interesting topic is how we can use generative AI in a responsible way, but in a creative way for their learning. That's one of the big demand in public school. Teacher cannot ban this one, but teacher need to set kind of regulation with the student, and teacher should provide how to use AI in a responsible and ethical, but in a creative way to enhance their learning. So that's my presentation. Questions?
Fantastic. So any questions from the room or those online? You can either unmute yourself or type your question in the chat and we'll relay that for you. Questions?
Keep themselves.
Yes.
So I know the concern with AI is the acceleration of mis and disinformation. It's likely to come out of it. I'm curious about using AI as a tool to teach students about that, and it seemed like maybe you were touching on that a little bit with the creating text, emergency text to parents. Did you do anything else along those lines, teaching students about
Not yet, yeah, not yet. But actually, we when you go to the ChatGPT website, there is a teaching with ChatGPT. There's a brief web page there. I think you can Google it and you can find it. And when you go there, there's some kind of a simple Q&A session, and it says that is ChatGPT say true, and it explains about that. So students should understand how ChatGPT generates text, and it's not based on the fact. It's based on the data set, right? So when students understand that mechanism, they will check the fact, and they will conduct the fact check, right? When they use the ChatGPT. So I think that's a very important question and quite demanding point that we need to work on. So first, I would like to let my students know that ChatGPT generate text based on something, not fact. So you should check it. Yes.
I was wondering, does the teachers who use the AI to teach the students in the classroom also use the AI to generate teaching materials for other class?
Sure.
Because I read AI can also be used for differentiation, generate more content or puzzles, for example.
Yes, yes, yes. I totally agree. Yeah, that's a good question. Yeah. Yeah. Even I use ChatGPT to generate some questions for my student. Yeah, yeah. Because recently one of my EDD students want to have a qualifying exam, and that area is not my expertise area. So I would like to check out what's the kind of front issue in this, that area, and I got some kind of a basic idea from the ChatGPT, and I also searched articles regarding that. So it is kind of starting point to shape our idea. I think we can use ChatGPT more responsibly and creatively, and I would like to let our students also use it.
I have a question. So Purdue is very interested in AI. They're putting a lot of emphasis on physical AI. So what are some things you would advise us in terms of educational applications for physical AI?
Good, yeah. Actually, my student, the Gunje, who showed the demonstration, he studied in the tangible AI learning tools. So as I mentioned, the AI concept itself is very abstract. We cannot see it, we cannot feel it, right? We cannot manipulate it. But tangible AI tools make this one as more visible and touchable. So when we use the kind of teachable machine, we integrate the pose, and this pose itself is not related to AI, but this one is related to the quality of data that training AI and the quantity of data to training AI. So based on this experience, students learn better. So as provide interest me, I has another NSF grant that using the mixed reality. In the mixed reality, we want to teach the abstract city concept using the embodied learning activity. Through their embodied learning activity, they can ground their abstract concept into their bodily movement. It's more concrete and tangible. So tangible AI learning tool make it happen like this. So makes the abstract concept more visible and trainable or traceable. So make the black box approach as a white box approach. So what's going on inside there, and let students experience it. Yeah, I think that is a good approach, especially for the young kids. By the way, I heard that Purdue has a AI delivery robot.
Yes.
I never see it here. Not this morning.
They're all over you.
Oh,
Yeah. Do you have them about you as well?
no.
Yeah.
I don't know, yeah, but I
Yeah.
want to say, I saw that robot in in different university, and I took the picture like that, because it was interesting.
Yeah, especially at lunchtime, you'll see a lot of. All right, we have about 3 more minutes. Any other questions?
I was interested in the black box approach.
Yeah.
And especially with regard to students being able to examine the data
Mhm.
to understand why the output was as it is, especially with regard to identifying bias
Mhm.
in the data, weaknesses in the data. Can you talk a little bit more about that?
Okay, so one of the group says XAI, so explainable AI. Previously, as I mentioned, the black box approach is here's a training data, and here's an outcome AI model, and we're gonna use this one. Yeah, but explainable AI, that group want to make this process is visible to the student. So, for example, deepfake. One of the journal article is related to the deepfake. So the curriculum is like this. Here, how the AI create fake image or fake movie using the deepfake technology, and let students understand the mechanism, and even let students detect which one is generated image or which one is generated a movie. And there's some kind of, even the technology improved quickly, right? So it is now really difficult to tell the difference, right? It's like what's the real money and what's the fake money, something like that. It's really difficult. But there's some kind of mechanism that detect AI generated image. And during the process, students understand how AI work with the data and how they correct their image based on that algorithm. So I think that kind of approach make it more understandable to the student. It's a growing area, so
Yeah.
there are
Yeah.
many other approaches will go up. So.
All right. Well, Dr. Kwon, thank you so much. Very fascinating. I'm sure we'll have a lot more questions during lunch, so appreciate it. All right, we're going to transition to our faculty grad student panel. And it's probably easier if you just want, you can stay there, or we can have everyone come here at once. What would you prefer? You guys just want to come one at a time, or do you want to sit up here?
I'm gonna sit up there regardless.
All right.
I'll take that choice.
Let's have the panel members come up, get up chairs. And while they're coming up, let me go ahead and do an introduction here. So we have, starting off with Professor Chang. Kwon is a professor of educational psychology and research methodology. He's going to be talking to us about data science research and applications in the educational psychology program. Hey, student panel members, come out too. And I think we need one more chair. One more chair for the front.
Right there.
And after we hear from Dr. Chang, we'll hear from Yuxiao Zhang. He's a PhD student in educational psychology and research methodology. He'll be talking about using cognitive modeling to get diagnostic information from student classroom assessments for college STEM instruction. We'll then hear from Xiuxiu Tang. She is a PhD student, also in educational psychology and research methodology. and she'll be talking about how to use process data to improve classroom accuracy and PISA assessments. And then we'll hear from Professor Bill Watson, Professor of Learning Design and Technology. We'll talk about leveraging AI for personalized systems of education. And Wonjin, a PhD student in Learning Design and Technology. We'll talk about meeting where they are, addressing AI integration barriers through K-12 educators' perspectives. So with that, we'll start with Professor Chang. You should have about 10 minutes.
First of all, thank Dr. Kwon very much for his excellent presentation. He provided us a big picture of the landscape. I was inspired and encouraged. Okay, today my presentation or my panel discussion is about what we are doing at College of Education. First of all, I want to say a few words about the history. Actually, AI, large-scale AI application started in education. Started back in 1960s, 70s at the University of Illinois. At that time, people there developed a system called Plato. Plato system provided courses to thousands, millions of students. And the idea is to promote individualized learning. In order to do that, they need to learn programming. They need to do collaboration, computer scientists, content experts, and educational researchers. And they need to involve this pedagogical design and and also assessment. Also, they invented at that time plasma. Plasma screen was invented at that time.
Wow.
Okay. That was many years ago.
Touch screen, right? They could touch the screen.
Yeah,
Wow, back in
the touch screen back in 1968. That's that picture. And now, and why we are doing our current research? That's because in order to promote individualized learning, we need to have a assessment to assess how much students learn, what's the students' learning profile, so that we can route students next. So I appreciate Dr. Kwon pointed out the difference between AI and automation. I believe automation is just like assembly line, but AI is adaptive automation. Just like you driving Tesla, if you drive a regular car, it still can cruise control. But Tesla's cruise control is adaptive. If somebody just jump in front of you, then you can slow the speed, something like that. So we need to do this educational research to introduce our method. And our method is called computerized data testing. Computerized data testing is according to the students' progress. If students do well, the next question will be more difficult. If students could not solve the problem, the difficulty level should be lower, something like that, so that we can always measure students precisely. Also, now our field has been developed so rapidly because of AI application. And now not only we need to know students, exact location, but also we need to identify why two students that to score the same, why their learning profile are different. If we can classify the learning status, then we can stimulate, we can route students to the knowledge points he has not mastered yet. Just like Newton system, I read article from Time magazine back in 2013. It's about personalized learning paths. And here, these two pictures actually are taken from real application. Just we went to high school, then teacher teach the same content, but the starting point are same, but the learning routes can be totally different from two students. And how can we do that? Then we need to use a model. So today, my emphasis is more like we try to open the black box. So what is inside the black box? As the methodologist, and we develop these methods, specific methods for specific applications. And just like a learning model, actually, we want to measure students' score. From the students' score, we can identify students' learning profile. From the students' learning profile, then we route students' learning intervention. Then we make the students again. So again, should have some mathematical model inside. The mathematical model, people use different model, and we use, then that method is developed, is just like just unlike people just talking about ChatGPT is so wonderful. Then we are going to decipher what is the algorithm, how can we do step by step. And now in educational psychology and research methodology, our group, we have a very strong faculty body, and we teach students many these required fundamental courses. And just like the multivariate regression, structured model, meta-analysis, classification, latent variable modeling, and so on. All these classes are very important. That's different than computer science, than mathematics. So we try to teach in a way all students in college education can do well. And now the good news is recently the university and the campus, Purdue University launched a very big program called AI of master degree. And many of our courses have been selected as required courses. So if you, in the future, if you want to produce AI in education degree or AI master degree, then many of our courses can be selected. That's good. And then our second research emphasis is about measurement. Hey, we need to constantly measure students' progress and try to get what students really need. And then we need to use cluster theory, and we need to teach a cluster theory, diagnosis modeling, item-based detection, and something like that. But nowadays, our emphasis is about how to help personalized learning. And now it's just like Newton. Newton, the system was built many years ago, and I believe there are so many things we can do to further improve. So we need to create methods, not cheaply borrow existing tools. And this is, I was so encouraged by listening to Dr. Kwon's presenting. That means there are so many things we can do. And also currently, we use our research to help large-scale class teaching. At Purdue, we have some STEM classes. These STEM classes are so huge, like 2,000 students and 3,000 students per class. And now, how can we help teachers to get students diagnostic information? Because we try to make learning more individualized by using the technology. And then, just like here, and we use, this is from another university, and we just developed some algorithm and just analyze teachers' old examinations, these items, we calibrate them, we build item bank, we use AI to manage that. Students can get online, and they can do all kinds of things. Then teacher can get diagnostic report. Student can also get diagnostic report. And also, this is a current project we collaborate with several universities, and that system is very famous in physics. We call it LESO, and now currently 100,000 students enrolled in that system, and then our students, I should say, our students are writing this code to help, and also our students learn that this training. Actually, they are doing very well, and our students graduate. They are working at the university, testing company, also including Google, Microsoft, IBM, and Amazon Web Services. This is Dr. Wu. He is the first students, in graduate at Purdue. Because I'm relatively new. This is my 6 years. Okay. And now another thing I want to say, just like 1 minute, it's about we have a pupil lab. We encourage faculty, students to come to us if you need to AI help, if you want to psychometrics, like this data analysis. And now we have these students volunteer, and also our postdoc, our RA can get you help. And this is, yeah, I will stop here. Thank you very much.
Thank you. Fantastic. All right. Yuxiao.
Are you this one?
Yes.
This one.
So, hello everyone, my name is Yuxiao Zhang and I'm currently a third-year PhD student in educational psychology and research methodology. So first of all, thanks Dr. Kwon's insightful presentation, and also thanks Dr. Chang for introducing our project. And Dr. Chang has touched some points, but I will dive into some more details. So as today our topic is about artificial intelligence, so I first want to make some connections because between my presentation and artificial intelligence. So as we know, artificial intelligence is to stimulate human intelligence, such as thinking, reasoning, making decisions within a machine. So the AI system can be highly complex, but usually it relies on some statistical or algorithmic basis to perform this complex task. So in education, one AI application is the intelligent tutoring system, which can provide students personalized, individualized learning experience. But how can such a system be as intelligent as human to provide students such tailored and personalized instruction and help? It needs to based on some statistical models to provide the information. So one model is the cognitive diagnostic model, which powers the intelligent tutoring system, and which that is what I'm going to introduce today. So for CDM, a starting question is, how can we know not just if our students are learning, but what exactly they are good at and struggling with? In traditional assessment, it usually produces a single score, a number summarizes students' performance. It is very useful in many situations, like to select students to be admitted, to rank students, to give students certifications, but at the same time, it do not provide sufficient information for educators who need to identify specific areas where a student is struggling. And cognitive diagnostic assessment can pinpoint exactly what skills need to be focused on for improvement, so which allows for targeted educational interventions. It is crucial in modern education because personalization is more emphasized. So here is a simple example about elementary math, what kind of information we can get from traditional assessment and the cognitive diagnostic assessment. In traditional assessment, we can know the student score, like the student score is 70, the student is in the 60th percentile in the national or local norm, and the student score above the cutoff, so he passed or he or she passed the test. But for in cognitive diagnostic assessment, it can produce more fine-grained information, which is helpful for teacher to tailor the subsequent instruction, such as we know the student mastered addition and subtraction, but need more work on multiplication and division. So here is another example. Although two students, they have get the same score in the test, but their actual knowledge mastery might be different. Like for the students in the left side, he mastered the first two skills, And for the student in the right side, she mastered the first and the third skills, but need more work on the second and the fourth. So here, if we go back to the example I used at the beginning, the intelligent tutoring system. So our cognitive diagnostic, how our cognitive diagnostic models power such a system. Actually, it is very similar to the classification algorithm used in artificial intelligence, like we are familiar with, like in online shopping. There is a classification algorithm to identify which type of customers you are, and based on your previous behavior, what kind of items you might be interested in, and then it can recommend the items you might appropriate for you. You might be most interested in. So in educational settings, the user is learner, and the items to be recommended to the learner is the learning materials. And we based on what to recommend the appropriate materials to learners. We base on what student mastered and what students don't master. It is called the skill attribute mastery profile. And how can we get such fine-grained information? What students know and don't know? We need a psychometric model, a statistic model, which is the cognitive diagnostic model here. So as we can see, the CDM can power intelligent tutoring system to provide materials based on skills a student has or lacks, creating a personalized and adaptive learning environment. So the next part, I will go to a specific step in cognitive diagnosis models. So basically, the underlying mechanics of the cognitive diagnosis is in an assessment. We get student data on the test questions, which question student correct, which is incorrect, and we want to map such data into a set of skills, so we know student skill mastery. But how can we complete this mapping process? We need to use a tool called the Q matrix, which defines which question has which skills. That is an important tool for us to derive the diagnostic information. So here is a simple example of the Q matrix we use. Like in the first item, it measures the first two skills, but not the last two. But not the last two skills. So the Q matrix is very important in cognitive diagnosis process. Without the Q matrix, the diagnostic information derived might be misleading and unreliable. It is similar to to a map. When you want to get your destination, you need the right map. If your map is incorrect, you cannot get the right destination. So as psychometricians, we spend a lot of effort to get an accurate Q matrix, so we can be more confident on the diagnostic information we provided to the educators. Basically, there are several steps to validate the Q matrix. But the basic idea is first, we have a panel of experts develop the initial Q matrix, which defines the relationship between the test items and the skills. And then after collecting student data, we will use the data as empirical evidence to validate whether the initial Q matrix is supported by the data. And if there is any inconsistencies, we will return the suggested changes to a panel of the experts, and they will review to decide which makes sense and which not, and finally get a make the Q matrix as accurate as possible. So this is to ensure we can get the most accurate and reliable diagnostic information for teachers and educators. And here is an example of our original Q matrix and the revised Q matrix. So this process is similar to the process in artificial intelligence. When we, like the machine learning model learn from the data, our Q matrix learn from the actual test response to improve itself. And not only based on the data, we have the panel of experts to review what data tell us and to make the final decision. This is similar to the human in the loop to ensure our algorithms recommendations align with the expert understanding. So the last part is about our project. We are still at the initial stage, but we can get some diagnostic information for the basic educators. Like basically we have school level, class level, individual level information to show, like in a school or class, what is the percentage of students mastered each of the skill being tested. And for individual students, what is the part need further work and which part is well mastered. So that's all for my presentation. Thank you.
I think you shall. Next, we have Xiuxiu. Yeah.
This one, yeah.
Yes.
Hi everyone, my name is Xiuxiu Tang. I'm a fifth PhD student in educational psychology and research methodology. The topic I'm going to introduce is the use of process data to improve measurement efficiency of PISA. So as you may notice, more and more large-scale assessment, including PISA, have switched from the paper pencil test to the computer-based assessment. When we take a test on computers, a lot of behaviors are involved to answer each test item. For example, we may need to, of course, we have to look at the screen. So we have the eye tracking data, and we need to use the mouse to move and click on the screen. And sometimes we need to highlight some sentence or words on the test items that better understand them. And of course, we need to spend time to answer each test item. So as you can see, we can obtain a lot of information when we answer each test item. With computer-based assessment, a larger amount of data from the process can be automatically recorded in the system. We can not only obtain students' responses, like whether students answer the item correctly or incorrectly, we can also get the process data, which is associated with the response process. As I mentioned before, it has like response time, eye tracking data, and the clicking and moving on the computer screen. And here is an example of the process data. The student answer a math question. This question asks the student to fill in the box here, black box, so that to make the number sentence correct. So, and on the right hand of the slide, you can see that this is the process data associated with the answering process. Like it records students' ID number and all the events associated with the answering process, like students opening a calculator and typing 21 plus 8 and etc. And we also have the response times associated with each event. Okay. So now we can easily access those process data. What can we do with them? Actually, there are many uses of process data. For example, we can use process data to explore potential reasons for examining correct and incorrect responses of certain item types. And also can use process data to understand why how examiners plan, select, and evaluate different operations to achieve the problem-solving goal. And here I listed 2 examples that researchers use process data to investigate the students' problem-solving skills. And they use the famous PIAAC and the PISA data. And among different types of process data, response time is the most frequently used process data because it is very easy to obtain. The system can easily record the student's response time data. And when I Google the response time, I got this result. It shows that response time is the length of time taken for a person or system to react to a given stimulus or event. But in the scenario of students' assessment, response time means that the time the examinee spends to answer a question. Here, many researchers are interested in response time because they believe response time can provide additional information about examinees and the test items. For example, we may notice that when the testing time is short, students do not have enough time to work on all the test items. Their accuracy on the test is generally reduced, right? This is the within person speed accuracy trade-off. And also, different test items may require different levels of labors to solve them. For example, like essay items, students need more time to finish them, while easy questions like or simple questions like multiple choice items, they need less time to finish them. Many studies have been conducted to use the response time to explore examiners' testing behaviors and the features of the test. Some of previous students of Dr. Chang did some interesting studies. Like they use the response time to detect compromised items, and they use the response time to detect students' potential cheating behavior. And some of them they use the response time to improve the memory efficiency. So many interesting studies. In short, incorporating response time to the measurement process could provide valuable information for us. And the focus of the study is to improve the measurement efficiency for PISA assessment. So here I will give a brief introduction of PISA. PISA was developed by OECD and launched in 2000. And in the cycle of 2015, PISA started to deliver all the assessment by computers. And later in 2018, PISA used a multi-stage adaptive testing design to assign different test forms to students of varying ability. So the purpose of using MST here is to further improve the measurement accuracy and efficiency for students of different abilities. And based on the history, we can see that PISA is now administered on computers, so we can have access to the process data. So this brings to our study. As I mentioned before, the focus of the study is to improve the measurement efficiency for PISA. And the traditionally measurement efficiency is solely assessed by the number of administered items required for a given estimation accuracy. But actually, we think that the amount of time examinees spend to complete the test should also be counted to assess the measurement accuracy efficiency. So in our study, we propose to incorporate response time to the testing design to improve the measurement efficiency for PISA assessment, especially for people at the two ends of the proficiency range. And in our study, we propose a 2-item selection algorithm, which not only maximizes the information per expected response time unit, but also best satisfies the content constraints. Okay, we did a simulation design, and this is the details of the design, but I'll skip this one for the time sake. And our study shows that by incorporating response time in our algorithm, the item selection method resulted in more accurate estimation of examinees' abilities across all different groups. And also, we can get a shorter test times as well as more similar test times across examinees than the algorithm without using response time. So based on our study, it suggested that incorporating response time in the measurement process may help improve the measurement efficiency for the large scale assessment like PISA. That's all about my presentation. Thank you.
All right, next up we have Professor Watson.
Yeah,
That what you really sent to me?
I sent it to her.
Yes.
Okay.
Is that, you sent it to me? Yes, it's gonna take me a second.
Sure.
Or do you have it on?
I have it on here, but I don't know if that's plugged. So
Okay.
Whoever set that up, any quick
Bear with me,
Okay,
folks.
okay.
Sorry.
I have one question for Xiuxiu. So how easy is it to get that process data from PISA to do research with?
Actually, the process data is public to everyone. You
Really?
can download the data from their website.
Wow, okay.
Yeah, they publish a lot of their data.
Very good to know. What about for Nate?
It's just such an.
Data for Nate as well. Nate, you have to apply. You have to apply.
You're sending me this.
Yeah, you
Interesting.
can just go to their website.
I do have a question.
Okay, thanks.
Xiuxiu.
what kind of
You might
data
want to
PISA
temporarily
has?
unshare your
Such as
screen.
math level,
Reading
I have a
Reading
and
question.
science. Yeah, math, reading, science are the three main subjects, but I think they also have other measurements. But I can't remember things.
So there's a kind of elementary level, middle school level. Okay.
Oh, the assessment is only administered to 13-year-old teenagers.
Just
Yeah,
after middle school, so middle school and high school.
no,
Age
yeah, age-based, because they only
based,
care about 13 years.
13. Interesting.
I can go ahead and start.
Yeah, okay, go ahead and then we'll get your slides caught up with you.
Yeah, so I love seeing this because if we're looking at Purdue's new online masters in AI, they're doing two tracks. They're doing essentially the developer track and then what they're kindly calling the leader track, which is those who are using AI but actually not developing it, right? So there's two different tracks of people, students, and then they will work some together so they can learn how to speak each other's language, right? So I'm in learning design technology. My background I started as a computer technology lecturer at IUPUI before I went back to get my PhD. And part of that process was learning that while I could program, that's not what I wanted to do the rest of my life, right? So I firmly am placing myself in what I'll kindly call the leader track of envisioning how we use AI without fully understanding how these wonderful people actually make it all work behind the scenes, right? So hopefully I think you'll find my presentation helpful. And if you, like me, are really interested in how to leverage it without fully understanding how to actually get in there and make it happen by yourself. So my background and my research is focused on leveraging technology for personalized learning. And that goes back largely to a focus in systemic change and systems thinking, which essentially is arguing that rather than trying to change our existing system, which was designed to do things that we no longer need, to meet our needs, we designed a new system. And that idea is essentially that our current system of education is the same system of education our grandparents, our great-grandparents, going all the way back to the industrial age, where essentially it was designed to compare people to each other and to separate them into either people who are telling the others what to do or those who are replicating the same task over and over again. So we haven't needed that sort of approach in a very long time. Even if you're working on today's assembly lines, you're working with high-level technology, you're solving complicated problems. We no longer have people who are doing the same job, whatever field they're in, over and over again for many, many years. They're constantly having to adapt collaborate, solve new problems. So if we understand that our goal is not to compare people and to separate them, but that to ensure mastery across the board, then what needs to shift is that instead of having time being the constant that's always driving things forward and that we're always following the calendar, we treat everyone the same, we give them the same content, and they either learn or they don't. They either acquire learning deficiencies, or maybe if they're able to go faster, they are able to speed up and move forward. If we don't hold time constant, then that means everyone's on their own path. They're learning in their own way. And so schools and instruction that are following that are going to look very, very different, right? Currently, we treat all 12-year-olds like they're the same, right? You're in this grade, you're the same, you're learning the same content at the same time when we know that they're different. So if we're not doing a time-based system, if we're really doing a personalized system, then we don't have things like grades, right? We have truly personalized paths where everyone is learning what they should be learning at that moment in the way they want to learn, okay? So my work in the past has looked at, one, how can we make that shift from a time-based system to a personalized system? And two, what does that look like and how can we utilize technology to leverage that? So AI has been on my radar for a while, but it's really amazing how quickly things have suddenly jumped forward where it's very apparent and it's everywhere. You know, we've had adaptive learning, these sorts of things for many, many years, but suddenly it's being applied and people are using it and they're able to get their hands on it. So I have a 11-year-old and, you know, traditionally we've always had the schools using their tests at the end of the school year where they're comparing the students all to each other. They all take the test and they're still doing that, but those tests now are largely being used to evaluate the schools and the teachers. They're also doing testing during the year where it is adaptive testing and the students go in and so NWEA MAP is what the local school system is using for that. And essentially when those students go and take that test, it is going through and they take the test until they've gotten an equal number right and an equal number wrong. And it's adapting the questions and their difficulty level based on how many they're getting right. So it's adapting while they take the test. And I, as a parent, in the past, my son gets a B or a C on something, and I can try to contact the teacher, and I can try to say, I don't really understand why he's struggling in this. You know, he's a really strong reader. He reads well. What's the problem here? With that map, they can actually go in and identify exactly where his deficiencies are within that issue. So for us, like we realized that despite him reading a lot, there are certain areas of vocabulary, particularly around language. I was an English major, so that annoyed me, but you know, whatever. Where he was struggling, like idioms and metaphors and these sorts of things. So while the teacher also has that information and can try to make sure he's closing in any gaps that are popping up there, we as parents can also look at it and say, oh, maybe we're going to be having him read this sort of book or do this sort of project. So that level of personalization is here, it's being used. And I teach our technology integration course, which is often with teachers, but it's amazing how the last time I taught it last year, no one talked about AI, right? And this year, 70% of them were already using AI to support themselves. So the other aspect we have with a personalized learning approach is it is by nature learner-centered, right, instead of teacher-centered. One hat I wear is around game-based learning and using games as a form of instruction that can motivate students, because I eventually went back to get my PhD because when I was teaching technology students, I had two very distinct groups. I had kind of the traditional college student right out of high school, and then I had those who were returning from industry and had already been working in the field for a decade and were now getting their degree. And the motivational and learning management skills of those two groups were so profoundly different that it made me reflect and say, what is going on in the K-12 world where students are coming out completely unable to manage or even largely take interest in their own learning, while those who have been away from formal education for 10 or 15 years are highly motivated. They're trying to squeeze all their learning out of every second. What is going on there? And that's what led me to go back and start looking into this. And part of our work was looking at learning management systems. Plato was a big one going back to the 60s, like we mentioned, and how they have morphed over largely to course management systems, okay? So going from the intent of we're going to manage all of your learning throughout your life to we're going to manage your learning in this particular course, and then when it's over, it's gone, and we're not sharing any information going forward or doing any of that.
I don't know if we're too far into it.
Yeah, I can jump forward real quickly. I always just blab and jump around anyway. So So part of our early work was looking at what would a truly personalized learning management system look.
Where do you want?
Yeah, I'll drive from here
All
if I
right.
can.
Yep, you go right ahead.
Okay. Let's see. Part of our work looked at what does a truly personalized learning management system look and how can we make that happen? And we called that a PIES, Personalized Integrated Educational System, because the term LMS and course management system had both kind of already been taken over by these one-off sort of course offering management systems rather than managing the entire learning system. And so at a very basic high level, what are the major things that a personalized learning system is doing? It's managing student data for where they're learning. What did they learn? What do they need to learn next? What's required? What is something that they want to learn that might not be required? How are we hitting on their standards? How can we use their particular interests in areas to drive learning in other areas that they might not have the motivation in? How can we plan for their learning and how they like to learn and how they learn most efficiently? What is that instruction going to be? How can we assess them and keep a record of that and keep track of all and manage all the stakeholders who are involved in learning? Ideally, we have parents involved, or if parents can't be involved because of their work, we have sponsors who are involved. We have the teachers obviously involved in the students. We have the instructional developers, the technology people. How can we manage all that sort of thing? So all this kind of goes back to, we studied a alternative school within a school district that was trying to transition to personalized learning. And while the larger district, we were conducting training for them on mindset change, on why personalized learning would be a good thing, we realized that there was this alternative high school in the middle of the district that was already doing many of the things that we're talking about. And the students in there had been kicked out of the main school and been put in here because they were failures. And they had one principal and one teacher for about 130 students who had been kicked out of school and never succeeded in it before. And by going to a personalized approach, the students were able to manage their own learning and suddenly see, I'm not here for X amount of time and X amount of years. I'm here for, these are the things I have to complete to graduate. And I can choose to learn that in any way I want, whether it's a traditional lecture or whether it's computer-based or whether it's doing create a project and meet those competencies, and then I'm done. So the discipline problems went away. They were able to work around. Some of them had their own children or had to take care of younger siblings or had to work to help their parents. They could work and do things on their own time. So truly personalized system. So I'm going to broadly, we have a chapter I'll point to if you want to get more into this, but the idea is personalized learning shouldn't refer to a specific tool, but to the process of what we're doing. And that is that has a lot of theory that supports it. And we are looking at development of student self-regulation skills. So their love of learning, their motivation is really important. Intrinsic motivation, mastery is valued. So we're not looking at efficiency, we're looking at effectiveness, that they've actually learned what they're supposed to learn rather than the calendar is moving and we're going on regardless of what learning deficiencies they have. Even though it's personalized, we're going to have a lot of social integration, a lot of collaboration. Collaborative skills are very, very important. We are going to empower learners to make their own decisions about ends, priorities, and means, okay? So that they feel in control of their own learning and they know how to manage their own learning, right? When I looked at those college students I had coming fresh out of K-12, they had learned how to be passive over their years in school rather than how to manage their own learning. We're trying to personalize instructional goals, the task environment, meaning how they learn, the scaffolding of instruction, how we're assessing them. We can personalize how they are assessed as well, how they're reflecting on their own learning. And that is the publication that goes into more detail about that and how we're envisioning. So why I'm so excited about AI is that suddenly these tools are available where when we're envisioning PIES, we're like, and somewhere over here, this is going to happen, right? And we're not exactly sure how. But AI has really allowed us to do a lot of things. Talking about the 2 sigma problem is essentially the idea of how do we meet the gap between one-on-one tutoring and instruction, right, and where we are actually in the classroom. And AI is really allowing us to create intelligent tutors who can give that one-on-one sort of feedback, instruction, identify where someone's struggling, where they need to go next. This has already been talked about, so I'm not going to go into a lot of detail about this. Just for those who are at a broader level, I wanted to share some of the key terms out there and how they kind of relate to that. Don't have time to talk about them, but essentially the computer systems are able to serve the teacher. So the teacher, instead of having to I'm going to design the instruction, I'm going to present the instruction, I'm going to run the assessment, I'm going to plan where they're going next. AI can do a lot of this to really support them and say, I'm flagging this particular student who seems to have a learning deficiency in this particular area, and we need to help them close that gap. We need to meet with them. They are motivated to learn in this particular area. They love sports, so let's do math about baseball, batting average calculations, and this sort of thing. AI can do a lot of this really intense, high level of time commitment work for the teachers. And it doesn't mean we're replacing the teachers. It doesn't mean there are no teachers around, and this is all computer-based. It's about automating time-consuming tasks. It's about helping the teachers and the learners be more efficient and effective in their learning. That's been the big challenge around deep learning, things like problem-based learning, game-based learning, is the amount of time and how inefficient it is, even if the learning outcomes are better. And some of our quick challenges here have already been mentioned: bias identification and mitigation within the models, cost and accessibility, like any technology for people, being human-centered, meaning we're not displacing humans, we're centering what's going around on helping humans, and the human in the loop, again, that we have humans who are seeing inside the black box and verifying and looking for issues like accuracy and bias. Data oversight, all of this runs on student data, so we have to be careful about protecting student data if we're accessing it, transitioning to ethical and accepted use. And then AI is extremely powerful, and there are bad agents and people who are looking to do bad things with the data who are actively using it in very scary ways already. So we have to keep an eye on that as well. And I ran over, so apologies.
Thank
you.
All right, last but not least, we have Wonjin, and
So, yeah.
Wonjin shared something about, again, meeting them where they are,
Share your screen.
addressing AI integration
Share
barriers
on
from
that.
K-12 educators' perspectives. I think it's a great way to wrap up this section by looking at how teachers are grappling with this.
You're gonna start sharing your screen. Get up there on the screen. Okay.
Hello, everyone, and hello, online audiences. My name is Wonjin Yu, a third-year PhD student in the LDT program at Purdue. Yeah, it's a great honor to have my presentation here. So, in this presentation, I'd like to introduce my research my advisor and I have worked on so far. So, yeah, meet them where they are, addressing AI interrogation barriers through K-12 educators' perspectives. What a great title, right? Okay. So, yeah, previous presenters already mentioned about that. Yeah, we are already using a lot of AI technology in our daily lives. AI technology is already prevalent, right? So I will skip this, and I will, introduce one thing. Personally, yeah, there's one thing. I experienced one thing recently related to AI. Yeah, let me show you one thing. So actually, my wife is pregnant. Yeah. Thank you so much. So due is October 7th, so very soon, right?
Wow.
Yeah, so my wife and I met doctor and took ultrasonic photo, and we were surprised. Why? We are living in the world that where AI technology can predict my baby girl's weight. Yeah.
Wow.
Wow. So due is soon, so let's see. Okay. Here's the reason why I showed this picture. Yeah. I'd like to mention, everyone's reactions. Someone might think, yeah, very cute or interesting, or someone might think, wow, what a great AI technology advances. Or someone might think, someone might feel uncomfortable feeling, to see unexpected AI development, right? Then what about students? Students may think of AI as some different thing, right? So previous research studies point out the misconception on AI. Dr. Kwon already introduced the concept of black box, right? So students, when they're using AI, they cannot see inner mechanism of AI. So they think of AI as a magic box that can do everything, or monster, right? So considering this, many research studies have discussed the need of AI education with the concept of AI literacy. And our governments, institutions around the world have prepared AI education into K-12 level. And also many governments, specifically South Korea. I'd like to introduce two countries first. So South Korea, South Korean government announced a plan that they will start AI education into K-12 national curriculum by the 2025 period. So for the K-12 levels and government, and they have selected several co-teachers and several leading schools that can operate AI pilot programs in advance to 2025 period, and the number of them has ever been increasing like this one. And United States, as you can see, we can find several both informal and formal education settings related to AI education. And also I'd like to add AI for rural as well, AI for K-12, CSDA, and so on. And United Nations and United Kingdom and so on, many countries and institutions have discussed AI education in the K-12 level. So in my research, I wanted to try to focus on listening to teachers' voices because they will take charge of the role of implementing AI education in their classes to their students, right? So I try to listen to their voices. So my advisor and I have conducted smart structure interview with 12 South Korean teachers and 5 K-12 educators in Indiana, in the United States, from last for 2022. So we vet them using Microsoft Teams and transcribe, translate the interview transcripts, analyze them into using schematic analysis. Here is the conceptual framework I use. So Dr. Alderman's various framework. So she suggested the teachers' barriers into 2 criteria: first order barriers and second order barriers. So first order barriers is related to the external environment from the teacher, such as infrastructure, the level of curriculum, resources, time, access, and so on. And the second order barriers relates to the internal environment from the teachers. So the level of confidence, misconception, burden, and so on. Based on this, I try to analyze the interview data and classify the barriers into 2 criteria and try to find other new findings. So here's our finding. So I found 3 themes related to the barriers. The first theme is training, and more training to resolve first order barriers. This theme is related to the first order barrier, right? So I can introduce several exceptions like this one. Some teachers said that only 10% of the K-12 teachers had taken the training, and we need more training to have better understanding of AI, like this one. And the second thing is related to second order barriers, that strong teachers buy-in resulting in fewer second order barriers. So I can introduce several exceptions here. When I met several teachers in the interviews, they said that everyone or many teachers already agreed on the need of the AI education. But some said that it might be some challenging, or I don't have any confidence, or I have some burden about it. So we were able to find several potential psychological barriers through the interviews, but some of them presented their bright future of the AI education, like this one. I can introduce the South Korean context here. In South Korea, they already successfully integrated coding education into K-12 level in the prior experiences. So some teachers said that it would be better than before. Yeah, software education as well as the coding education. And the third theme is a desire to go deeper and further with AI education. So many teachers point out that AI education, the future AI education should be should cover fundamental things like broader and more meaningful aspect, and it should encourage students to think about what they want to do with AI, like enhancing problem-solving skills. But we found several potential barriers, related to them. They wanted to reference several examples, many examples. They wanted to take trainings, but there were several barriers to do so. It may be from education system, or it may be from cultural context, or it may be from work context. But yeah, our further study will analyze and investigate it further. Okay, so our finding, I personally, at the beginning of the data analysis, I assumed the first order barrier and second order barriers like this, the diagram. But I found that first order barriers and second order barriers like this one. So I found that the lower second order barriers than the first order barrier. And I found potential third order barriers that influences both to first order barriers and second order barriers. So it can be, something like that. So our further study will analyze the relation with them. So my advisor and I developed one education program. So by expanding the existing program, we will pilot and publish the program for K-12 educator like this one. So we have this one. So we will develop, pilot, and publish. Okay. So this research is supported by the Care Lab at Purdue. So if you are interested in it, you can see the website. Care means computer science, education, artificial intelligence, education, robotics, emerging technologies. Okay, and here are the our members here. Dr. Watson here, right? Okay, so actually, we are revisiting the Innovate data to deepen our data analysis, and we are planning to review it at the ACT conference this year. We will have several sessions there, and we will present our deeper analysis at the webinar in this November. So just for reference. Okay, thank you so much.
Let's take a few minutes for questions because again, we got a great panel here that we can jump into lunch. So I want to thank these guys. This has been a really informative session. I've learned a ton. I got a ton of notes, a lot of questions, so I'll probably be emailing you guys. But questions, either from those online or here in the room.
And Wayne, I'm going to interrupt you. I have to apologize. I have to run to another presentation. I'll be back in about 20 minutes.
No worries. We'll save you a lunch. Any questions? I guess everyone's hungry. All righty. Well, I think our panelists and our keynote speaker will be sticking around for lunch. So feel free to mill about the room and then we can continue some informal conversations. I'm sure they would love to hear your experiences and ideas with AI education as well. And hopefully this will be starting a great discussion. So again, thanks to our panel. Thanks to Mike for the technology help. Thank you, Julie, for arranging things. If you have RSVP'd and reserved the lunch will be there to leave the instructions for grabbing lunch.
They're labeled, there's ham, there's chicken, and there's veggies.
All right. Thanks so much, everyone.